Wonderful. Oh, now. Okay, hi. My name is Maggie Menken. I am an instructor and developer at Hackbright Academy, a local boot camp. Yeah, right here. How many of you have heard of Hackbright? All right, cool. No need to introduce then. We graduate hundreds of women developers every year. So without further ado about this talk, I went to PyCon for the first time this year. And yeah, it was so fun. After 3 years of doing Python, it was very, very fun for me to be there. And I noticed that this thing called Dunder Slots kept coming up. And I was like, why have I never heard of this? And why is it so hot right now? So I was like, that Hansel is so hot right now. No one? No Zoolander? Okay, that's fine. That's fine. All right. So to explain what Dunder Slots is, first we have to know about dictionaries in Python. So dictionaries in Python are very fast, but heavy. And by that I mean they take up a lot of memory. So here we have a dictionary that contains cat facts. So we have a bunch of keys at first. If we add 2 keys later on in our code, Python's going to make room for those keys. And if I had, 10,000 keys in that dictionary, Python would be like, I can handle it. I got you. I'll make room for your keys. So the reason why dictionaries are fast is because they hash keys and values. Python stores the hash and what it points to in the dictionary, provides direct access via hashing, but it takes up space. So Python makes more space for your dictionary as it grows in size. As it gets bigger, it might, take up a lot more space depending on, how at capacity that dictionary is. So moving right along to objects. Objects store their attributes in dictionaries. It's a nice little dog foodie type of a thing with Python. You can see the instance attributes of an instance with that syntax there, and you can see class attributes of a class with some class.dunderdict. Here's an example. So we have a cat class here. The species is our class attribute, and we have one instance attribute called fur color. I'll talk about hunt for mice in a second. But again, if I make an instance, I can access the instance attributes with dunderdict. And I can see my class attributes in this funky little dict proxy. Species, here it is, cat. So, a little look into the internals of Python there. That's kind of cool, but when is this not cool? Well, again, dictionaries take up a lot of space. So, it might feel, if you're making tons of objects, it might feel like you're living in a mansion when you only have enough furniture and stuff to fit in a 1-bedroom apartment. A problem that none of us have living in the Bay Area. Thank you. But in other places, maybe they know what that feels like. So enter Dunder Slots. Dunder Slots lets us. So let me start with the fur cat here. We're defining Dunder Slots as basically all the instance attributes that my cat class is allowed to have. And then species is fine there. We don't have to define species inside Dunder Slots. It's just about the instance attributes. So when I initialize a cat, I'm good. I can still assign the fur color because I've provided for that in my Dunder Slots tuple. That can also be a list. There's a little bit of confusion about which is better. But I use a tuple because I love tuples. And then when I call my hunt for mice function down here, this actually throws an attribute error because I'm not allowed to create an attribute called hunting, right? I didn't provide for that in my Dunder Slots. So it's a little limited. Thank you. So why would you use slots when you don't want to internally store instance attributes as a dictionary? But when do you want to do that? When you know your object will only need a particular set of attributes, no more than that in its lifetime. And this saves an incredible amount of space. So using the memory profiler that Mahmoud presented in his performance talk this morning, I made 20,000 of my regular cats, 10,000 of my regular cats, 10,000 of my fur cats with their Dunder slot defined. And it looks like the amount of space that my regular cat takes up is quite a bit more than my fur cat, 10,000 fur cats. So there's 20,000 cats for you. Going back to my slides. Warning, don't prematurely optimize on this. This only saves you space when you're making like thousands of different types of objects. There are several examples on the internet for when that would be useful. And that's all the time that I have, so there's one more warning, but thank you very much. Again, I work at Hackbright, and there's my Twitter if you want to tweet at me. Thank you.
Hey everyone, so my name is Tim, and I am here to talk to you about Zulip. So Zulip has sort of an interesting story for an open source project. It actually started out as a startup back in 2012. Basically, me and my friends from MIT were doing our second startup. Actually, one of my co-founders was famous Pythonista, Jessica McKellar. And we built some great technology. We had excited users, and we got some acquisition interest. And ultimately, we ended up selling the company to Dropbox in 2014 while we were still sort of in private beta. So there was like a ton of press speculation about what cool thing Dropbox is going to end up doing with Zulip. But we ended up, when we got to Dropbox, sort of wanting to work on the most important problems, and that actually turned out to be Dropbox itself. So a few months later, the Zulip leadership was actually running the main Dropbox product across Mac, Linux, and Windows, iOS and Android, web, and APIs. So basically the whole thing. And this sort of meant it was great for Dropbox, great for us, but not so great for Zulip. We kept it running, but there was sort of no new development on the project. So this is usually the point in the story where next thing that happens is Dropbox shuts down Zulip. Nobody ever uses Zulip again. The end. But that's actually not what happened. So the users of Zulip were really enthusiastic about the product. They kept on emailing us asking if there's some way that they could come do something to fix some bug that was bothering them, that kind of thing. And we ended up sort of working out a solution where Dropbox open sourced Zulip last fall. And if you've ever tried to open source a project, it's actually like a ton of work. And it was sort of difficult to figure out how we were going to staff that. And actually, the solution that we came up with is that 10 users of Zulip actually came to Dropbox headquarters for the annual Hack Week and did all the work to open source it, which is pretty awesome. And so that's sort of how Zulip became open source. It's actually the users set it free in a certain sense. And we've really built sort of an amazing community since then. So I'm really proud of what we've done. We have a very welcoming community, and we've done a lot of stuff sort of technically to make it easy to contribute. There's over 40,000 words of developer documentation, really good test coverage. We have this cool parallelized linting system, and a great sort of system of having project chat hangouts basically to try and figure out how to help people be productive on the project. And the result is that we have over 150 contributors to Zulip from around the world. It's been translated to Chinese, all sorts of cool stuff like that. And there's dozens of people who are contributing regularly. And this is all sort of powered by the Python community. So we use Django pretty extensively. We're use Tornado for our server-side push system. We're actually sort of at the leading edge of Python in the sense that we're using the MyPy static type system for Python across the entire code base. The work to sort of actually type most of the code was actually done over the PyCon sprints just a few months ago, which is a pretty fun party. And we now, basically because of using MyPy, have moved the project to be fully on Python 3. So that's pretty awesome. And the other thing which is really cool is we have this sort of the graph of contributions going into Zulip over time. You can see sort of we had 11 full-time engineers working on Zulip before the Dropbox acquisition. And since Zulip was open source, it's actually now the case that the project is moving faster than when we had 11 full-time engineers, which is pretty amazing for an open source community. The main problem that we've been experiencing is a lot of people want to use Zulip but don't want to run their own Zulip server. Pretty understandable for a lot of organizations. So to solve that problem, I'm actually now starting a company to run Zulip for people. So we providing hosting, enterprise support, the usual things that open source companies do. We actually just a few weeks ago moved the original beta user base of Zulip onto our servers, and so people are super happy to be running on a well-managed system again. And that's sort of the high-level story. Our sort of overall goal is, I think that everybody should be using open source software. The world's best software should be open source software. And we're sort of working on that, starting with chat, since that's where we are. If you're excited about that vision, you can pitch in on helping us out. Get your open source project to try Zulip. We'll host it for you for free. You can have your company try Zulip. We'll host it for you. And join the Zulip developer community. We are very welcoming. We love new contributors. We're happy to take people who are less experienced with Python and help them get up to speed. And just in general, contribute to open source. I think ultimately the world 20 years from now is going to be one where almost everything that people use is open source. And what you do today can help make that happen sooner. So thank you very much. And come chat to me after if you have any questions about Zulip or how to build an open source community.
PEX in 3 minutes. Eventually, I said 3 minutes, not 5 minutes, because I can't not go over time. So this way I can go over time, and it's all OK. And yeah, I'll get to the PEX in a bit and what that is. But first, cool Python program, mycli.net. It's a MySQL interactive terminal, and it has uses the prompt toolkit to give you really cool, tab completion of SQL commands and stuff. And I'm a Python developer, and I want to install this thing. So I know how to install, Python programs that I see. Pip, if you're really smart, you make a virtual environment first, but you turn your virtual environment on, you pip install the thing. Some stuff, it says some stuff, but then eventually I get to type mycli, and it starts up my cool new MySQL command line client with auto-completion and good stuff. So as a naive developer, I thought, hey, that's how you install tools. That's how I'm going to deploy my software to my server. And I'm really smart, so I'll automate it with Fab, but basically, I'll pip install. That's what you do. And pip install from my requirements.txt or whatever. But that's a deployment strategy. What could possibly go wrong? A lot could go wrong, it turns out. If you don't care about PEX, you should take away from this talk, pip is not a deployment strategy. Thank you. That only works if PyBay is up, and it's usually up now, which is really cool, but it's not always up, and it only works if your server isn't firewalled. And when I installed on my Mac, I got wheels, and there's only sdists if you're installing on Linux, but it worked on my laptop. I'm sure it'll be fine on the server. And then if it's not fine, my deployment script has to account for a failure. And what if I had two servers? Man, things could get really complicated. So I said PEX. There was going to be something about PEX here. So PEX is an open source Python project. It's created by Twitter. It's available at github.com. Pants build PEX. Pants uses PEX, and there's been some Pants talks. But you can also use PEX as a standalone utility, and I think it's super useful, and people should know about it. PEX is a utility for building PEXs. Of course it is. Make a virtual environment, turn it on, pip install PEX. PEX, mycli-e, there's a bunch of stuff, but that basically is the PEX equivalent of pip install mycli. And you'll notice on the next line when I run pip freeze, I did not install it into my virtual environment. I don't have anything installed except for PEX. And in fact, I'm done with my virtual environment, so I'm going to turn it off. What I did was make an output file there, mycli.pex. PEX is a utility for building PEXs. Cool, I have a PEX. Weren't you supposed to yell at me every minute really loudly and funnily and stuff?
Oh, I mean, you said after 3 minutes. You're 20 seconds away from 3 minutes.
OK, I'll wait. Anyway, so what is a PEX? A PEX is just a zip file. So if I unzip this thing and just look randomly, zip is happy to say it contains a bunch of files, and I see them scrolling by, and there's .bootstrap and .dep.
You lied to me. It's 3 minutes.
Ask for that. But if you look at the prefix of the zip file, it has a text prefix that looks kind of familiar. User bin env python 2.7. So this is an executable. You can run it. / I'm running a zip file that says the Python interpreter should run the zip file, and it just works. What's going on? Why does this work? So a PEX is a Python package and all of its dependencies in a self-contained file. This does not contain a Python runtime. So this is not like a CX freeze kind of thing where you're building an executable that you could just ship to some other system and run that does not have Python installed. But it does have everything else that you need, and you really can do everything else that you need if you'd like. PEX creates for you a main execution entry point. I had to tell the entry point that I actually want to run when you run the PEX. There's various other things you can do with PEX. It fixes up my Python path to say, hey, look in a .deps folder, and it puts all my dependencies there. If I kind of inspect the zip, there's a bunch of wheel files that represent all my dependencies. And if you've ever visited PEP 425, you'll know that you can request dependencies for specific operating systems, for specific Python versions, for specific ABIs of specific Python versions, et cetera, et cetera. So you can tell PEX, hey, I'd like to build this with the dependencies not for, well, the platform I'm building it on, which is the default, but for some other platform. So for my laptop, I could easily cross-build. For some value of easily, what is this big error message telling me? It says at the bottom, could not get distribution for a thing on Linux x86 64. This is telling me that if I try to pip install PyCrypto on Linux, it'll grab a tar gz and sdist, which is great if you have a compiler and you're willing to compile it and all that stuff. Mini Linux is a solution to this problem, and PEX encourages you to just build the wheels you're going to use the -f flag to tell it, and here are my wheels, and you can build a WAR file. Like Java's had a .war file, right? Like you build this thing, and then your deployment strategy
Did you
is
tell me to
you
yell
run
at you?
the thing. Yeah, yell
Right?
at me.
Yeah,
5?
Yeah, Grace is telling me not to yell at you.
Yell at me. That was going to be funny.
Yeah.
So a .war format for Python is a great honking idea. We should do more of those. And SCP, now that's a deployment strategy. Just copy it and then run it. Yeah.
We went over 5 minutes.
Cool. So you all have a good weekend? I had an awesome weekend. So my name's Andrew Baker. I work on the documentation team at a company called Twilio, and I just moved here to the Bay Area from Washington, D.C. like 4 weeks ago. I was really active in the Python community in D.C. I've been, attending Python events for a long time, and so I was hoping that I was going to receive a warm welcome here, but you guys have totally blown me away. It's just been really, really touching. You all are an incredibly warm bunch, and I'm really glad to be here. So thank you. So you probably heard a lot about some really cool things from all the talks, and now you're just like itching to go and learn a whole bunch of new stuff on your own time. And so I thought it would be a good point to reflect on maybe the best way to do that. But before we get there, I wanted to tell you where I'm coming from. This is Andrew Baker circa 2012, a bright-eyed, clean-shaven IT consultant based out of Arlington, Virginia. And he worked in this example of DC brutalist architecture, which was home to the Consumer Financial Protection Bureau. All right, yeah, CFPB. So CFPB was kind of doing open source development in government before it was cool. A lot of people who work there have moved on to the digital service and 18F and stuff like that. This is the first public-facing website that I built, which was a Spanish version of a knowledge base that they had. It's a Django site. It was my first real big Python web application. And I actually got an email from the developers who are maintaining it the other day talking about what a great job I did. But I was really hungry to learn more after that first experience, and so I started working on the weekends in coffee shops, maybe even a few late nights, just trying to satisfy my curiosity about this wonderful new world of open source web development. And I also got into this thing called Docker. I heard a lot of people talking about it. I didn't understand it. I'm not a Linux expert, and I'm still not a Linux expert. But I decided to dig into it, and so I built my own Docker-based platform as a service called Spin Docker using Flask. I knew straight from the get-go that no one was ever going to use it because there were already better tools out there. But I documented every single endpoint in it anyway using Sphinx. And this was the way that I discovered that I have an unhealthy obsession with documentation. And it turns out people wanted to learn about how to use this Docker thing, so I started running workshops in DC, and that's how I discovered my passion for education. So these side projects really helped me discover what got me excited about different parts of my job. And I liked doing side projects so much that I saved up my money for a while, took a break from my consulting job, and spent a couple months just hacking on whatever I wanted. And I'm sorry to report that I decided to dig into Node.js, and I built this thing called Hypermasher, which was mashing up Instagram hyperlapse videos with SoundCloud playlists. And you may have actually seen it in the press if you read Spanish Gizmodo and Japanese Lifehacker. But all that experience got me to put a proposal in at PyOhio, and I spoke there, had a great time. I put in a proposal for PyCon 2015 and spoke there about Docker. And then all those credentials helped me land at the job I have right now at Twilio, where I've been for about a year. But since then, my side project story hasn't been so rosy. So this is my personal blog. The most recent post is from January 2015. And if you go to hypermasher.com today, this is what you're going to see. And people have been noticing and tweeting me about it. And I actually got another issue filed on one of my side project repositories like last week, asking me, why is this not available anymore? So I decided it was time to rededicate myself to side projects, but I went out on the internet trying to find advice for it, but what I really needed was side projects for average human beings. So I started with my coworkers, and I work with this one guy called Greg. Greg blogs super consistently. He has a really consistent personal blog, and he also runs a newsletter about software development and depression. And Greg is very open about talking about mental health issues in our industry. And so Greg's piece of advice is to publish incomplete, imperfect posts. So as soon as he puts some words down on paper, he will publish that post to the internet. It's live. If you go to Greg's website, you'll see it. And he says that is more than enough motivation for him to come back to it the next day and finish the job. I also work with this guy named Matt Mackay. Matt runs fullstackpython.com. Matt's advice is to ship something every day. He will spend at least 3 minutes every day working on fullstackpython.com. And if you go and look at the repository, you can tell that he's not bluffing. The dude has been committing to it every day since 2012. But I also met someone really inspiring yesterday. So I met this woman named Melissa, and Melissa currently is not a programmer, but she's trying to learn, trying to change her career, and she is waking up early every day to work on Learn Python the hard way. She's about halfway through. And so Melissa talks about how she's tired when she gets home from her day job at the end of the day, but she keeps waking up, keeps saying that alarm clock early so that she can make this career change and make it happen for her. And this was the first time she'd ever come out to an event in our community. So if you see Melissa, give her a high five. If you have your own tips, tweet at me, and thank you again for such a great weekend.
Okay. Hi, my name is Nate Ani. I'm the founder of AppSembler, and we make it really easy for companies and organizations to deliver online courses. And oftentimes these courses have like a hands-on lab exercise that the students are supposed to do if it's like a programming course. And we observe that this can often cause problems for students and instructors. So what are those problems? Well, you get inconsistent lab environments, right? So you have different operating systems. Sometimes you have locked down laptops where you can't actually install anything on the laptop. And there can oftentimes be complexity in installing all the dependencies to actually, write some Python code if the student doesn't have Python installed properly. So the solution that we came up with was to give a Docker container for each student. And the benefits of this is that all the containers are identical, so you have more consistent environments for every student. And because it's running in the cloud, you don't have the problem with lockdown laptops. And it eliminates a lot of the friction in the install process. So people can get started right away because they have an environment, already has everything pre-installed. So the instructor has to deal with multiple environments for each student. With the Docker solution, every student essentially has the same identical environment. So I'm just going to give a quick demo of how this works. In this case, we're going to give each student their own Jupyter Hub notebook. So we start out with a base image, the Jupyter Notebook one. We just pulled this down from Docker Hub. And we create a container. We're creating a Docker container now. And this is looking at the perspective of the course author, right? So they're preparing this environment for student use. So we're going to launch this container. And it takes about 10 seconds to launch it. And you can see here that it's running. And so we click on this URL, and then it's going to open up that Jupyter IPython notebook. And it's empty because we haven't added anything to it. So now the course author can now upload their IPython notebook. And this one happens to be mining Twitter, data mining Twitter. It's a popular Safari book. So now we have this mining Twitter notebook uploaded for our students. And now we want to snapshot this environment and make it available for every other student. So we got this thing running. We just click this Save As Image, and we can snapshot that lab environment so we can reuse it for every other student. So we'll give that a name. And you can see that it's saving. And that takes about 10 seconds. OK, so now we're going to create a project that can be launched from inside our course. So we click on New Project, and we give it a name. And this is where you can decide how long you want this lab environment to run. So if you start it today, it's going to run for 4 days, and then it's going to shut down automatically. OK, so now we have that project created. Now we're going to jump over to our lab environment. And our course environment, we're going to add that lab. So we're now inside OpenEdX, and we have this little widget called a container launcher. And all we need to do is just put in the name of the lab that we want to launch. We can give it a friendly name for the student. And when we look at this in the actual course, it's just a button that the student can click on. And when they click on that, we talk to our API, we spin up the container, we give them a personalized URL that's ready for the student to start using right away. And when they click on that, you can see they've already got that mining Twitter notebook all ready to go. this is another example using Cloud9, which is a web-based IDE. So if you want to actually give the student their own IDE environment in the cloud, sorry, it wasn't running. I think I'm going to run out of time here. I'm just going to accelerate this. It's pretty much the same that you already saw. Oops. OK, something is broken here. OK. If you're interested in Cloud9, come talk to me afterwards. OK, so what's the stack look like? We're using Django, a Django REST framework. We have React.js on the front end. We're using Docker and the Docker Pi. And then to make this scalable, you're using Docker Swarm, console, the Docker registry, and then all the URL mapping is we're using something called Hipachi. And that's it. Do I have any time for questions? I'm right 5 minutes on the dock. OK. If you go to that bit.ly URL, we have a blog post that has these videos and more information about the solution. And you can also email me or tweet me. Thanks.
Jupyter Notebook for the slides here. So 538 is a very good blog post that writes a lot of data-driven stories. And they wrote a story about Fandango movie reviews and if they're overinflated. And they shared the data as well. So I'm going to use this 5 minutes to talk about the analysis. So here's the story. I'll just click on it so you can read through it later. So they compared the movie ratings of various rating agencies and said, are the movie ratings of Fandango, which also sells movie tickets, inflated? Okay. So and they shared the data as well in their GitHub 538/data. You can check it up later as well. So that is my source of my data set. I'm going to use Python's SciPy stack to do this analysis. Acquire data, you just load in a data frame. You just pandas data frame. And then you can look at one data row. You can see all the movie ratings by each movie there. And usually you have to clean up this data and you have to normalize it. You have to do a lot of things. That's where most of the time gets spent. But in this case, they did all of the work for us. So we'll take it. We'll just do simple histogram plots. On the top is the Fandango ratings, and bottom is the IMDb ratings. You can see Fandango is mostly 4 and 5, some 3s. There's nothing in 1 and 2. Okay, so there is reason to believe that. And then IMDb also is inflated, but it's not as much as Fandango. And then I'll jump to this. This is the user ratings, and you really see that the user ratings are actually well distributed from 1 to 5, whereas Fandango, is just 4 and 5s there. But let's build some machine learning model because we can. Okay, scikit-learn makes it really simple. We're going to build a decision tree regressor. Okay, and there's only 3 main things you need to do. You need to select what features you want to run the model on, and what's your target, and then run the model. Okay, so I'm splitting this into train and test because you should. And so I've taken a bunch of features, and then I'm building this machine learning model. This diagram is hard to see, zoom in, but the next one you will see. You'll see that it actually splits on user ratings, and then it's basically user rating that determines the Fandango ratings there. So I have a better picture of this. So I took a next model with just the user ratings. Okay, and here you could see that if user rating is less than 2.8, it goes to the left branch, and then it again splits. If the user rating is less than 1.3, then it says the Fandango rating is, the value there is 3. Otherwise, it is 3.7, 4, and 4.6. In the next visual, you actually see it much more clearly. Because this is a good one with the decision, but it's hard to see where the decision boundaries are. Okay? So here is a step function, which is very nice. On the x-axis is the IMDb user ratings. And 3 minutes, that's great. And then on the y-axis is the Fandango ratings. So let's just pause here, make sure we understand this. When the IMDb rating is 1.5 and below, then you see on the y-axis the Fandango ratings is 3.08. That is actually. So the lowest rating in Fandango is 3.08, and then when the IMDb rating is between 1.5 and 3, Fandango is predicting 3.75, and so on. So it's a nice step function. You can actually see, and it actually captures all the non-linearity that exists because ratings are not linear or distributed across all the ranges. Okay. And of course, we could overfit it. Okay, we could overfit it. So here I've gone to more depth. You can see that the second step over there, it goes up and comes down. That's a clear indication of overfitting that's happening there because of low number of data points. We have only 150 data points in this analysis. Okay, that's great. But then, this is a small enough data set. We should run statistics on it to see how the distributions compare. And this is the last slide. You can see the red one is the Fandango distribution, and then I have the IMDb and Rotten Tomatoes distribution on the left. If you actually do a t-test are the V's very different, you actually will not come out significant. But you can clearly see that it's Fandango is farthest to the right, but you cannot make a statistical significance that it is indeed different. But you don't need that, hopefully, for a story. So yeah, there is some evidence that Fandango is inflated, but you can't just make a statistical conclusion based on the data set that's given. Awesome. Thank you so much. And yeah.
Okay. Cool. So who here in the audience has used the ABC module in the standard library for Python? Cool. So ABC is great for people who haven't used it. ABC lets us essentially define classes that sort of implement or describe contracts for other classes, right? So if I do from ABC import star, then I'll say class animal meta class equals ABC meta. And then what this lets me do is decorate certain methods as required to implement some interface, right? So I can do like abstract method def, say eat, self, food, stuff, right? So in order to be an animal, I need to be able to eat. And then if I want to implement a particular animal, I can say, class dog is an animal, and def eat, self, food, barf, right? So this is great, and now if I make a dog, then everything just works. So if you look at this, you'd be like, okay, well, why did this help me in any way? So the nice thing about ABC Meta is that if I don't implement eat, then it will yell at me. So if I have some contract that I'm expecting to implement, ABC Meta can catch errors for me by telling me, hey, you didn't implement the interface you meant to. So if I do that and I try to make a dog now, it says I can't instantiate your abstract class dog because it still didn't implement eat. So that's great, right? That solves some set of problems for us. But there's a couple issues with that. So one of them is you'll notice that it failed when I tried to create a dog, even though it knew when I created the dog class that I hadn't implemented all the methods that were necessary to be an animal. So one issue is that validation happens at instance creation time, not at class creation time. The other, I think, more sort of serious issue is that ABC Meta doesn't look at your function signatures at all. It just looks that you have the attribute provided. So I can say eat equals 3, right? And my interface says that I should be able to call the eat attribute with some food. But as long as I put something in that eat value, then we're fine here, right? So that's sort of a little bit unfortunate. So there's two issues I see with ABC Meta. One is that validation happens at instance creation time, and the other one is that it's not doing any sort of signature validation. So Python gives us all the tools that we need to fix this problem. So I wrote a small library called interface. So if I do from interface, import interface and implements. And if I want to define an animal interface with interface, it looks almost exactly the same. So I say class animal subclassing from interface, def eat, self, food, and I don't put anything there, and maybe we'll make a def sleep, self. So this is great. So now if I want to say that I'm implementing the animal interface, I can say class dog implements animal. And let's make a couple mistakes here, right? So we'll say we just won't implement sleep at all, and we'll have eat take too many arguments. So I'll say def eat, self, food, drink, right? Maybe I thought that I could also eat beverages, but clearly that doesn't make sense, right? And we'll just pass here. So the nice thing about interface is it'll yell at us about this, and it'll give us a nice, useful error message telling us exactly how we didn't implement our interface. And it's at class creation time, too. So it's not when I tried to make an instance of dog. It's as soon as I made the dog class, it yelled at me, and it said two things. One is the following implement methods just weren't implemented at all, right? I just didn't implement sleep. And the other one is that the signature of the eat method didn't match the signature that was expected from that animal interface. So it expected a method to look like eat of self, comma, food, but it got eat of self, comma, food, comma, drink. That's essentially the whole library. There's a couple other tricks. So you can implement multiple interfaces at a time. So if I have like animal and, I don't know, noun, right, something like that, I can implement multiple interfaces. And it will sort of take the union of all those possible checks. It's also intelligent enough to know things like if I add a new argument with a default, that's still an acceptable implementation of the interface. So even though the signature doesn't exactly match, it's compatible in the sort of Liskov substitution sense. But yeah, I just wanted to show this off. This is sort of a neat hack. It's about 300 lines of Python. You can find this on GitHub at ssanderson/interface, and you can pip install it as Python interface. I think it's neat. I've used it for a couple little toy projects. I'd love to get people using it for more serious things. But yeah, you can pip install Python interface and ping me if you have questions or deep theoretical concerns. Thank you.
Different candidates in a lot of different positions and fields, and I need some commonality on how do I interview a candidate. And one thing that I really like to do is to give them a problem called TicTacToe. And everyone knows what TicTacToe is. I think some people attended the talk yesterday. But I want to show how to implement it, I think, in a fairly self-contained way. Mainly, this is a way for me to do some live coding in front of people. So we'll see what I can do. Now, if you know TicTacToe, we have a game board. It's a 3x3 matrix. So immediately, if you're going to represent the game state, you're going to represent it maybe a matrix. Well, I'm going to do it a little differently today. I'm going to do it as a list. And the reason I'm going to do it as a list is because I'm going to try to do it within a compact for loop. So I have here some tests that are going to test most of the win conditions. And I've got some PyTests going. We see that since nothing's been implemented, we all fail. Let's try to implement the case where we have no winner. So when we have no winner, we're just going to return none. And that should say no one has won. Well, there's also a case where we have a draw. And the draw, I would say, should be if none is not in board, then turn, let's just say D for draw. And so we're going to see our failure count go down 1. Now, let's get into the real nitty-gritty of it. Let's try the horizontal cases. So the naive solution, let's do every single possibility. And we're going to start with the first one. So if board 0 is equal to board 1 is equal to board 2, you can probably see where I'm going with this. And we'll say and board 0 is not none. Then we're going to return board 0. So what this says is if we have x's or zeros in the first row, we'll return that letter. We can make this a bit more generic and say, well, we have to cover this second case as well and the third case. So we're going to say we're going to have a start value. And the start value will be maybe 3 plus 0, 3 plus 1, 3 plus 2. We're covering the 3, 4, 5 case here. Obviously, that's not very generic. We're going to say start. And just copy paste, make myself more efficient. And of course, what I'm doing here is I'm trying to build up my generic implementation. I'm going to put this in a for loop. So for start in 0, 3, 6. We can do better than that. We can probably say, hopefully this will work. OK, we've gone down to 2. Thank you. Now let's put this in the win conditions list. In the win conditions, we're going to put, here, simply 0, 3, 6. So start in win conditions. So we've filled out our horizontal. Let's try the vertical. Now the vertical is a little different because we're going to, instead of going 0, 1, 2, 3, 4, 5, 6, 7, 8, we're going to say 0, 3, 6, 1, 4, 7, 2, 5, 8. So we can say start plus, well, it's not going to be 0, 1, 2. We're actually going to have a stride. So we're going to do a stride. And this will be a 1 times stride, I believe. Let me go to my cheat sheet. Blah, blah, blah. Yes. And then 2 times stride. Fill this out. Thank you. So we also have to write this loop in a for. I'm going to make a tuple here. We're going to put the stride value as the second argument in a tuple. So we're going to do a for stride, or sorry, starts, stride, in win kins, and this will actually become start. Our vertical now becomes 0, 1, 2, and our stride is 3. Now if we extend this, we can also do the diagonals. The first diagonal is 0, 4, 8, so we know we start at 0. We're going to go by 4, and the second diagonal will be starting at 2 and going by 2. And if I didn't make a mistake, we should be on a complete, where was it? 25, 25, start and start, thank you. Oh, okay. Didn't do it. Oh, well. But if we go to our game complete, it's pretty much exactly the same. Thank you. So game complete. We'll have our winning tic-tac-toe has one in a 2D for loop. So if you're interested in DSP or audio, please come talk to me. Dolby is hiring engineers of any kind of programming language. Thank you.
Good try.